So in this question, we've got a hexagon, and it's given us the vectors O to A as the vector A, and the vectors O to B as the vector B. The first part wants us to say, what is the vector A to B in terms of the vectors A and B? We can't go directly from A to B because there's no vectors there given. But what we can say is we can say A to B. Well, we can go from A to O first, and then go from O to B. We have the vectors O to A, which is the vector A, but that's O to A, and we're going from A to O, so we're going against that direction. So we're taking the negative vector, so that's going to be negative A, so we're going against it. And then O to B is this vector here, so plus B. That's the first part. Now, this next part says there's a line AB, which is already there, that is extended to the point K so that AB to BK has the ratio 1 to 2. Okay, so the best thing to do here is in your diagram or on your book, on the paper, draw that line. So AB is extended, so I'm going to keep going a bit further. And it says AB to BK is 1 to 2. So I know that B to K is going to be twice as long as A to B. So it's best to draw it as accurately as I can just to help us see things better. So A to B is there. I'll probably say K is about here, I'd say. So I want to find the vector CK. So I want to go from C to K. And as you can see, there isn't a direct vector that goes from C to K. But what we can say is, we can say, well, if we want to go from C to K, we can first go from C to B, and then we can go from B to K. So C to K, we can go from C to B first, and then B to K. Okay, so let's find CB then. So we want to find the vector CB, but there isn't a vector given on the diagram that says CB. But can you see, because this is a hexagon, these lines O to A, so there's this line here and this line here, these are going to be parallel lines, aren't they, because of the shape. So O to A has the same vector as C to B, it's in the same direction. So C to B, we can also call it as the vector A. It's the same direction. And because we're going from B to K, B to K is in the exact same direction as A to B, but it's just twice as long. So in the question, it's given us that BK is twice as long as AB. It's going to be 2 lots of the vector A to B. It's going in the same direction, just twice as long. So BK is twice as long as AB. So that's that vector A plus 2 lots of the vector AB, which we already did in the first part, and that's going to be negative A plus B. Then just simplifying it, got A plus 2 lots of, well, it's going to be negative 2A plus 2 lots of the vector B. And then we have negative A plus 2B. So that's that part done. That's part B. Okay, so here we've got a triangle OAB, and it's given us the vectors that O to A is the vector A, and O to B is the vector B. The first part says find the vector A to B in terms of these other vectors A and B. So we can't go directly from A to B because there's no vectors given in the question directly from A to B. But what we can do is we can go from A to O first, and then go from O to B. So not directly A to B, but we can go from A to O and then O to B. So O to A is given in the question, O to A, but we're going against that direction, O to A. So we're going to be taking it to be negative a. Because O to a is positive, but we're going in the other direction, so we're taking it to be negative. And then we can go from O to b, and it's just going to be plus the vector b. That's the first part done. Okay, so next part says P is on the point AB such that AP to PB has the ratio 3 to 1. So I know that AP here is going to be 3 times as long as PB, which is 1 here. And we want to find O to P in terms of the vectors A and B. Okay, so I guess the first part here is to say the vector, so we can go from O to B by going from O to A first, and then going from A to P. You can go the other way and go O to B and then B to P, but I'm going to go this way. So O to A and A to B. You should get the same answer regardless. Okay, so O to A, we have that already in the question. O to A is the vector A. And then we want to go from A to P. Okay, so A to P we can write a bit differently. We don't have the vector A to P, but what we do have is the vector A to B, which is what we found in part A. We have that A to P is 3 times as long as B to P. So actually, we have that AP is 3/4 the way from A to B. So AP is 3/4 A to B. So we've got the vector A plus 3/4 of the vector A to B, which we have in the first question, which is negative A plus B. So if I just kind of expand this out a little bit and get vector A plus, well, take away 3/4 that vector A plus 3/4 of B. So these are underlined just to show that they are vectors and not the actual vertices. So I've got A, take away 3/4 of A, so I'm just left with 1/4 A plus 3/4 B, and that's my answer. So my answer is 1/4 A plus 3/4 B is the answer to part B. So the main thing is just using what you know in part A for your answer in part B.